Good morning, students. How are you all? I hope you all are fine and healthy. Children, we are doing chapter 2 motion. And in my last video, I discussed about speed, uniform and non-uniform motion and average speed of a body. Okay, now in this video, we are going to discuss about mass and weight, which is also the last topic of this chapter. After completing mass and weight, we will be doing the numericals. Okay, so children, you have been studying the difference between mass and weight since your junior classes. So let us just recapitulate what is mass and what is weight. Mass of a body is the quantity of matter contained in it. You know, everything around us is made up of matter. So, what is mass? Mass of a body is the quantity of matter contained in it. Means how much matter is there in a body becomes the mass of the body. We can measure mass by using various units like kilogram, gram, milligram, but SI unit of mass is kilogram. Next is weight. Children, we often get confused between mass and weight, and usually daily, like speaking in our everyday life, we often get confused between mass and weight, and we usually use the word weight when we are calculating the mass. But this is wrong. Weight of a body is the force with which earth attracts the body. You know that there is some gravitational force, the force with which earth is attracting everything towards itself, that becomes the weight of the body. Okay, so SI unit of weight is Newton and other units are kilogram force and gram force. Okay, mass multiplied by the gravitational force of the earth. Let us see the difference between mass and weight. First difference between mass and weight is the definition. We will first write the definition of mass, quantity of matter contained in a body. What is the definition of weight? It is the force with which the earth attracts the body. This is the first point of difference, the definition of both mass and weight. Second point is their units. The SI unit is kg, the SI unit is Newton. Okay, there is the difference between the units also. Next point is very important. See, mass is constant for a body and it does not change by changing the place of the body. Means the mass of the body remains same everywhere. If we are on earth, the mass of the body, if it is 5 kg, it will be 5 kg. If we are on moon or any other planet or on space, the mass of the body will remain same. But it is not same as weight. It is not constant for a body but changes from place to place. Okay, it depends on the gravitational force of the place you are in. If you are on earth, see, the weight of the body will be according to the gravitational force of the earth. If you are on moon, the weight of the body over there will be according to the gravitational force of the moon. Okay, so this is the major difference, mass and weight. Mass remains constant, amount of matter in a body will remain constant, will not change, but the weight of the body will change because weight depends on the gravitational force of the body, attraction that the body experiences. Okay, next is what are the instruments or devices used to measure mass? You can measure mass using a beam balance or a weighing machine, but weight is measured using a spring balance. Okay, so these are the differences between mass and weight, children. I hope you have understood. Let us just quickly revise. What is mass? Mass is the quantity of matter contained in a object. What is the SI unit of mass? Kilogram. What are the other units of mass? Gram and milligram. What is weight? Weight of a body is the force with which earth attracts the body. What is the SI unit of weight? Newton. And what are the other units of weight? kilogram force and gram force. Okay, when we will differentiate between mass and weight, first point will be their definitions, second point will be their SI units, third point will be that mass remains same, constant everywhere, even on changing the place, but weight can change from place to place. Fourth point is the device with which mass can be measured. It can be measured using a beam balance. Weight is measured only by spring balance. So, by finishing this topic, we have completed our chapter, lesson number 2, motion. Only numericals are left. So, children, what you have to do? You have to complete your question answers. Question number 19 to question number 23 are left. Complete them in your physics notebook. Okay. I am attaching a video with this. Children, I am attaching a module along with my video in which you can understand the concept of uniform and non-uniform motion, also the difference between mass and weight very nicely. Do watch those videos and be thorough with the topic. Thank you.
Let's accept it. Most of us think that mass and weight are pretty much the same thing. Are they? No, they're not. There's a very simple way to understand the difference. Mass is simply the amount of matter that's present in the object. Now consider two situations. One in which an object is on the earth, and second in which the same object is on the moon. Will the mass of the object be different in these cases? To answer this question, we ask ourselves another simple question. Will the amount of matter present in the object be different in these cases? Absolutely not. The matter in the object is not changing at all, which is why the mass will be the same in each of the cases. The mass of an object remains constant no matter where it is placed. The standard metric unit of mass is the kilogram. Another concept we'd learnt about an object's mass was that it is a measure of its inertia. Greater the mass of an object, greater will be its inertia. Inertia is nothing but the tendency of an object to resist change in its state of motion. So now we have an idea about what mass is. But what's weight then? How do we understand the weight of an object? Mass is nothing but the measure of how much matter an object has. Weight is a measure of how strongly gravity pulls on that matter. It's the measurement of the gravitational pull of an object. Let's understand this using a simple example. Say there are two places, place A and place B, and there's an object of mass m. In place A, the pull of gravity is x units, and in place B, the pull of gravity is 2x units. Clearly, the pull of gravity is stronger at place B. Now understand this well. The mass of the object will be m at both the places, but the weight of the object will be greater at place B because the pull of gravity is stronger. As the gravity is twice as bigger, the weight of the object will be twice as much at place B as compared to place A. So the weight of an object is a measurement of gravitational force acting on it. How can we understand weight using a formula? We know the Newton's second law of motion, which says that the force acting on an object is the product of its mass and acceleration. When it's acceleration due to gravity, we can replace A with a lowercase g. This force due to gravity is nothing but the weight of the object. So if we consider the weight of an object to be uppercase W, we can rewrite this equation as W equals m times g. So the weight of an object is the product of its mass and acceleration due to gravity. What will be the SI unit of weight? Can you guess? It'll be the same as that of force. Newton. As the value of g at a particular place is constant, we can also say that the weight of the object is directly proportional to its mass. Here's the main takeaway from this video. The mass of an object remains constant everywhere, whereas its weight depends on the gravitational force at the location. how do we know whether an object in motion is traveling faster or slower than another object? Consider two objects, Object 1 and Object 2, both moving along the same path. Just by looking at their motion, can you tell me which one of them is moving faster? Clearly, this one is moving faster. In comparison to Object 1, Object 2 keeps lagging behind. Hence, we say that the speed of Object 1 is more than the speed of Object 2. Speed is that physical quantity which tells us how fast something is moving. How do we define it? In order to know the speed of an object, there are just two things we need to know. First, the distance traveled by an object in motion, and second, the time it takes to complete that distance. Consider a car moving on a straight road. First of all, can you tell the type of motion it's undergoing? Since it's moving in a straight line, it's in a rectilinear motion. Suppose the time it takes to reach the other side is 30 seconds. Now consider another car which is similar to the first one. It's also moving in a straight line path adjacent to the first one. The time taken by this red car to cover the same length of the road is 40 seconds. The blue car covered the path length in 30 seconds, while the red car covered the same path length in 40 seconds. Which one of them was moving with greater speed? By intuition, we can say that the blue-colored car was traveling at a greater speed than the red one. Why? Because the blue car covered the same distance in lesser time. Let the length of this path be 420 meters. This path length is nothing but the distance that the car travels in a given amount of time. Now for each object, if we take the ratio of the total distance covered and the time required to cover that distance, we will get this. This ratio is called the speed of the object. Yes, speed is distance over time. Since this ratio is greater than this one, it means that the blue car traveled with greater speed.
Uniform motion and non-uniform motion. A body is said to be in uniform motion if it travels equal distances in equal intervals of time. A body is said to have non-uniform motion if it travels unequal distances in equal intervals of time. For example, consider a car moves from one position to another position about 16 meters distance within time t 8 seconds. Here, the car starts from O and after 2 seconds, it reaches position A covering a distance of 4 meters from the origin as shown. In next 2 seconds, it reaches position B covering a distance of 8 meters from origin, and in next 2 seconds, it reaches C covering a distance of 12 meters from origin, and in next 2 seconds, it reaches D covering a distance of 16 meters from origin. In this case, the car covers a total distance of 16 meters in 8 seconds with equal intervals of 2 seconds. It means that the distance covered by the car is directly proportional to the time. From this illustration, we can conclude that the car had travelled equal distances in equal intervals of time. So, this type of motion is known as uniform motion. Another example. Consider a car moves from one position to another position about 16 meters distance within time t 8 seconds. Here, the car starts from O and after 2 seconds it reaches position A covering a distance of 2 meters from the origin as shown. It reaches position B covering a distance of 8 meters from origin, and in next 2 seconds it reaches C covering a distance of 10 meters from origin, and in next 2 seconds it reaches D covering a distance of 16 meters from origin. In this case, the car covers a distance of 16 meters in each 2-second interval. From this illustration, we can conclude that the car had travelled unequal distances in equal intervals of time. So, this type of motion is called as non-uniform motion.